Polly want a cracker. We all know the trope. You stand in front of a cage, offer a simple phrase, and the bird repeats it back to you. For centuries, the scientific consensus was that these animals were essentially biological tape recorders, mindlessly echoing noises with zero actual comprehension. That assumption is exactly what gave us the insult bird brain. 17th century philosophers like René Descartes argued that animals were biological machines, completely incapable of conscious thought or reason. But human speech is incredibly complex. To form our words, we rely on a highly specialized physical toolkit, vibrating vocal cords, lips and teeth, and a massive frontal lobe to coordinate the timing. A parrot has absolutely none of those anatomical features. Yet researchers like Dr. Irene Pepperberg proved the biological machine theory wrong. Her African gray parrot, Alex, could count objects up to 6, identify 7 different colors, and actively apologize when he sensed his researchers were getting frustrated. To understand how a creature with a rigid beak and a brain the size of a walnut pulls off this illusion, we have to look inside its throat. Parrots are actively bypassing their own physical limits to speak our language. The first major obstacle is the voice box. Humans generate sound using a larynx located high up in the throat, but birds use an entirely different organ called the syrinx. This schematic shows the avian respiratory system. Deep in the chest, right where the trachea splits into the lungs, sits this Y-shaped structure. Sitting at the fork of the airway, the parrot controls the left and right bronchial muscles independently. It literally produces 2 distinct tones simultaneously, allowing it to match the complex, multitonal frequencies of a human voice. That solves the pitch, but it leaves an obvious articulation problem. Try making a P or a B sound without closing your lips. For an animal with a solid keratin beak, it's physically impossible. This diagram illustrates the inside of a parrot's head. Unlike most birds with thin, rigid tongues, parrots possess an unusually large muscular tongue. It moves back and forth, altering the throat's volume to shape raw sound into vowel formants. To handle impossible consonant sounds, it uses esophageal speech. The parrot uses its own throat as a pressurized chamber, trapping air and releasing it in a sudden burst to create the sharp pop of a consonant. With a vibrating chest cavity and a highly maneuverable tongue, the parrot functionally recreates the exact physics of the human mouth using completely foreign hardware. Having the mechanical tools to make a sound is useless without the neurological software to command them. Recent scans of the parrot brain revealed a unique dual pathway architecture that neuroscientists call the core and shell system. This diagram shows the distinction. Songbirds and hummingbirds have a central core region that handles standard vocal learning, but parrots evolved this distinct outer shell, a massive ring of extra neural real estate dedicated entirely to complex mimicry. Within that system is a very specific region known as the anterior archipodium. This region contains specific clusters of neurons mapping directly to individual pitches and acoustic elements. Reproducing a human word requires the parrot to activate these clusters in precise, rapid sequences, flexibly recombining its motor commands to match whatever it hears in its environment. This avian neural map is organized so similarly to the human motor cortex that researchers view it as a textbook case of convergent evolution, 2 entirely different species developing the exact same biological solution to speech. Which raises a crucial question. Why would a bird evolve millions of years of complex neurological software just to talk? The answer lies in how they live. Wild parrots are fiercely social, highly intelligent animals that mate for life and travel in massive groups. Their survival relies entirely on flock cohesion. Out in the wild, vocal mimicry is a survival tool. Parrots learn distinct local dialects to prove they belong to the group, and some species even assign unique individual sound signatures to one another, effectively using names. Take that highly adapted, deeply ingrained survival drive and place it inside a human living room. In a domestic setting, a parrot adopts our language to integrate into the only group it has. By mimicking human words, the bird is making a highly intelligent bid for social connection, treating its owners as the new members of its flock. Today, that social drive is paying unexpected dividends for us. Because the parrot's brain maps so cleanly to our own, scientists are actively studying it to design treatments for human speech disorders, like apraxia and aphasia. The next time a parrot speaks, Recognize the millions of years of evolution at work. Behind that mimicry is an advanced communication engine trying to bridge the gap between species just to be your friend.